Bismillahirrahmanirrahim. Let's discuss one of the most important application of dynamical systems in the field of linguistics, where we will be discussing the idea of language death. It has been observed that the languages are vanishing, and people are of the opinion that by the end of this century, by the end of this century, 90% of 90% of these languages will be destroyed. In other words, will vanish. In this regard, Abrams and Strogatz, Abrams and Strogatz proposed the following model. That's it. They said that consider x and y, consider x and y to be two languages competing for speakers in a society. Then the proportion, the fraction of population speaking X evolves as how it evolves. It evolves something like following. Here the fraction is the small x fraction of population is speaking X evolves as x dot to be equal to 1 minus x times capital P sub yx minus small x times P sub xy. So this small x is the fraction of the population in the society who speak the language capital X. What about these pyx and pxy? So basically the pyx is nothing but it is rate of switching from y to x, and this way p sub xy would be rate of people switching, rate of people switching from x to y. In other words, this is the rate by which the people will switch from y to x, and here x to y. So what next? We will consider the model where p sub yx is given as s times small x power a, and p sub yx is, sorry, xy is 1 minus s times 1 minus x to the a. So this is xy and this is yx. This is xy. So if I substitute these both values in the original evolution equation, then I'll get something as following, and it will be x dot to be equal to s times 1 minus, so what was the initially equation? So the initially equation was 1 minus x times p sub yx, and then we had minus x times p sub xy. So this has to be 1 minus x times p sub yx, and this is going to be s times x power a minus x times, this is p sub xy, and this is going to be this guy over here, 1 minus s times 1 minus x to the a. Or in other words, we get x dot to be equal to s times 1 minus x times x to the a minus 1 minus s times x times 1 minus x to the a. Now we have to show that this particular evolution equation has three stationary solutions, or three fixed points, or three equilibrium solutions. So for equilibrium solutions, or the equilibrium points, we set x dot to be 0 as always, and this will give me s times 1 minus x times x to the a minus 1 minus s times x times 1 minus x to the a to be 0. And I can snatch x times 1x as common, and then I'll get s over here times x power a minus 1, and then minus 1 minus s times 1 minus x to the a minus 1, that whole equals to 0. And from here we know that these three factors have to be 0 either. So either of them has to be 0, either x equal to 0, or this 1 minus x is 0, or this guy x times s times x to the a minus 1, 1 minus s times 1 minus x a minus 1 to be 0. From here we have x0 or x1, or from here I can rearrange this, and I can get what will I get? So s times x power a minus 1 to be 1 minus s times 1 minus x to the a minus 1. So these two are already over here, and x is 1, or so what will I get? I'll get s over 1 minus s to be 1 over x minus 1 whole power a minus 1, from where we get x to be 0, x to be 1, or we get this over here, and from here we get x to be 0, x to be 1, or so that is going to be s over 1 minus s to the 1 over a minus 1 to be equal to 1 over x minus 1, or these two are fixed point already, so third one will be coming from here. Let's simplify just this guy over here, s over 1 minus s to the 1 over a minus 1 plus 1 to be 1 over x, and this way x is 0 or x is 1, or x is equal to 1 over 1 minus s whole to the 1 over a minus 1 plus 1. So these are three fixed points. Let me give them. subscripts as x1, maybe x2. Okay, let me call this x3 and x2. Why? Because this guy, uh, x is the fraction, and it has to be between, for this case, 0 and 1. So this 0 and this 1, and this has to be between 0 and 1. This x2 has to be between x1 and x3. So what next? Next, we can show that these two x1 and x3 are indeed stable equilibrium points, and we can show that this x2 is unstable. But how? We can use linearization theorem. So for that we need the derivative of x dot. In other words, in this case, f of x was equal to, it's s times 1 minus s, and x to the a minus, then we have 1 minus s times x times 1 minus x to the power a. So let me find out its derivative. Indeed, forgive me, this is x. So s has to be over here, then I'll be differentiating this. So a times x to the a minus 1, and 1 minus x same, and then this plus 1 minus x will be, okay, so x to the a will be same, and this guy will be differentiated. So the derivative will be minus 1, and this way minus 1 minus s will be over here, and then this will be differentiated. So derivative of this is going to be 1, so 1 minus x to the a, then plus x will be same, derivative of this is going to be this guy over here times minus 1 by chain rule. So f prime at x is going to be equal to, okay, so from this bracket, if we take x to the a minus 1 is common, then we get s times x to the a minus 1 is common, so this will be minus x. And what we get here, so here this guy will go away, and we will get a minus ax. And then from this bracket over here, if we take 1 minus x to the a minus 1 is common, then we get 1 minus s times 1 minus x to the a minus 1 is common. So this guy will go, no, we will be left with 1 minus x, and then we will be getting, and we will get this x times a, but with minus a times x. But we can write this as s times x to the a minus 1 times minus x plus a minus a times x, and then this minus can be multiplied inside this bracket to get 1 minus s times 1 minus x to the a minus 1 times, so this will be minus 1 plus x plus ax. We can simplify it a bit more to get s times x to the a minus 1 times a minus x to be common, 1 plus a, and then plus 1 minus s times 1 minus x to the a minus 1, and then we have something minus 1 time plus x times 1 plus a. So at the end of the day we get this thing, and now we will calculate this at 0, at 1, and at maybe x star, and from there we will see how the result will look like. So for this you will have to be patient till the next video. Thank you.